How's it going, everyone? Elier Gonzalez here. Today, we're gonna take a look now at the particularly challenge made by the Nadeem Sim, a software engineer that has previously worked at Capital One and Google as an intern, and he made this roadmap as a way to understand how all of these particularly tools, computer science tools like data structure and algorithm, how they works to solve real life problems and what are the patterns occurring to that when it comes to solving. So it split that into this particular topics here initially as a data structure, and as you move on this particular game of life or down this roadmap, you start to see is now how all you need is, for example, is a algorithm as you move on in down to this path. So initially we look at the array and hashings and how you can actually solve. In today's course and in today's video, we're gonna use this ECMAScript, the latest syntax of that, and then also describe how all of these things fits together as a way to, when it comes to provide solutions to someone, whether it's your client, your business, shareholders, you name it, and ultimately your users, you know how to do, what to do, how that thing works, and be able to now describe that in the most effective possible, in the most effective way possible. Sorry, I'm a little right now. I'm quite congested. Yeah, how do you say that? Uh, I got a flu right now. Uh, yeah, but it's yeah, but my nose is stuck, so I have uh, I don't know. Anyway, my nose is not in the right moment. But yeah, I'm actually taking things to get better. So in any case, the methodology of this series of videos is to let's gonna let's go to briefly describe the first 10 minutes what we have done so far and what are the value proposition of each one of those problems that we have solved, and starting to uncover is all of this particular pattern and how we can also use now, for example, uh, solutions like Brilliant.org, especially for the mathematical fundamentals, to understand how can we generalize what actually are the things that we need to do, especially when you solve these particular problems using geometry, using visualization as a way to understand how all of these particular things will work, which is great. All right. Uh, and and then, well, when it comes to solve a particular problem, how by looking at things in different perspective is a powerful problem solving. So by thinking forward, which is what are the things that you can clarify quickly initially, and by thinking backwards, enumerate all the possible things that can happen. A lot of the time, this is one of the best way of how you can solve a particular problem. This particularly fundamentals here, and I know I'm talking like so. Yeah, my nose, as I mentioned. Yeah. So then we're gonna take now 20 minutes to actually solve a particular problem. Okay. How how can we come up with some solution for that? But this time it'll be much more faster because we know what we have to do. And then if we or if I couldn't solve that, okay, let's take a look now at the solution here. But the point of this is to actually see whether your initial thought, what is your naive approach, and then you can come up with something and see what are now is the pattern. So first we'll look at the context duplicate. The TLDR is that by using as a hash an array as a way to now count is the number of elements that you have in a collection. Valid anagram is as a way of how you can now work is with an array, with an arrays, by actually transforming those strings into an array and then apply some operations to that. So you can now convert and transform that in the way you want as a way to check if two words actually are an anagram or a valid anagram. uh, when you backwards, okay, it's actually the same. All right, they represent the same. So whether it's forward and backwards, those were read in the same. The two sum it was a quite interesting approach or problem because the idea is to now see how you can identify is elements in a collections and by using a hash map as a way to compare that, right? And how by using its representations, in this case, is like, well, you have now a hash map that actually, what is the thing that you want to store here in this hash map? And what are the things that this hash map allows you to do, not only to count, but also to compare them. So because this particular problem focuses on how you can now or find the two elements in this collection. So when you add them, it matches to a target, and then one is the index for that. So there's several things that they explain uh, in that premise, okay, that is uncovering all of the things that you, as you can see, the pattern that you can go with, uh, and that's it. It's like using now a hash map not only to count but also to compare that. All right, as you move on in a collection of elements, pretty much like group anagrams, you can actually is doing the same thing as a way to now check if those anagrams, which is an string, and when you convert it into an array and sort it, so you're now going to store all of those elements in your array as long as they are the same, or in your hash, as long as they're the same, and then you're going to store in its value. As you can see, you're using now a hash is not only as a way to count, but also as a way to group elements, all right, as well as to compare, as we mentioned before. And that's when now when you take a look at the top k frequent elements and the string encode is something that is quite interesting. These two exercise I really love about it because first it's something that we do a lot of the time, a lot of the time. So we want to know is what is the most frequent, for example, food that we eat today or in the last 3 months, or what is the most frequent place that we go to spend in restaurants as a way to keep track of finance. Uh, uh, the latest places that we have visit, that kind of thing. You know, all of these particular things, and I think that's quite convenient and important and interesting. So this is what's about that. How by having now this collection of elements, how by finding it what is the most frequent element uh, in each one of them, you're going to now use all of this particularly that structure as a way to come up with some solution. Remember that after all, because here we want to know is the most frequent elements, which is the way of how you can count elements in a hash map. All right, that's what we did. We count all of these elements in a hash map. We count is the number of occurrences, okay, and once we have that as in your record, all right, so then how can we now represent as a way to get is the most frequent arrays? We can use it as a way to any of these occurrence or any of these comparisons values. We're gonna now represent something in the array, okay, which is that uh, on the in the if you have an array that will be the same length as the collection that we receive. If we have this array, okay, Now we will want now on each index we want to know is the number of elements that happen in there, whether it's one time or three, 5, 10, you name it. Okay, and once you have that, all right. So once you now create that, and anytime you iterate through this array, uh, if that actually matches the number of occurrence, okay, that is when you're gonna put that elements there, and you want to do that using a set values. So okay, so because of that, all right, after you now populate all of these values in this array, you want to know what are the most frequent of them. So one way to do that is by starting to count from the last one, all right, and then split that, all right, to get the last elements out of this. It's like, hey, give me is now the last k elements from the end until I want to. So that was very interesting, very interesting problem. Very interesting because here you can see that anytime you are going to solve a particular problem, see that as a collection of values. Or first, read the premise and see what is all about this. Okay, what is the thing that you're gonna work with, especially if this is collection of value, you're gonna ask yourself, hey, if this is a number, this is a string, all right, and then you go if the problem needs to you to count something, record something, or compare something, using a hash can help you a lot. And also use now a way to represent another elements there. Talking about representation, string and NeetCode, it was a very interesting thing because this is how now by using is arrays, or in this case is string array, how you can store information inside of this string as a way to encode that, which is pretty much what is doing a lot of this. So, for example, encoding ciphers like Caesar, you know, Caesar encoding, or Caesar encryption, all right, and that kind of thing. So because of that, uh, we look at how can we now add some special information to this string as a way to now have all the information available when you need to decode that, and how by actually moving through that we can actually get that information that we need to. This is also something useful, especially if you're going to encrypt some data. String encode and decode. I also look at the product of array itself as a way to know what are the uh, product of all of the elements except itself, all right, by using a prefix and a postfix, and how you can calculate that. Value Sudoku, it was more like see how you can now work in matrix, okay, as a way to now not only identify unique values, which is using now a set for that in row and column, but also how you can do that now in matrix, for example, as a way to calculate if this on the 3 by 3 blocks in the Sudoku. This is where you want this to uh, check if there is unique values there, which is if this is a valid solution. How you do that by actually work with the index and then use some representation from that. Quite abstract, yes, I know, but the idea here is to be present when it comes to solve the problem, and also use geometry as well as generalization or algebra as a way to solve this particular problem. Visualization to me has been the key to solve this particular problem. Uh, The other is valid palindrome, as a way to see this particular phrase without the alphanumeric characters. When you reverse that, it contains the same, it reads the same, contains the same letter in the order, whether it's forward and backward, which is great. Uh, Sorry. And here we were using is now regex, which is this regular expression, or in this case, with this particularly methods that is provided for us when you use a string as a way to identify is this actually match the specific regex pattern, which is, hey, this is alphanumeric, or yeah, if this is alphanumeric, uh, yeah, if this is alphanumeric, which is, hey, if this match between A to C, or if this alpha or this is a number, all right. So by providing this particular pattern to this function as an input, now it will give to you is a true or false, and then as you do that, you're going to construct is your uh, palindrome. Reverse that, and they're going to check that. But the whole point of this is that it is important to use geometry here as a way to represent how you're going to solve this problem. And I think that's quite silly. Very, very silly. Oh my god. A lot of the things that we look in preschooler, oh my god. Or in kindergarten, god damn it. A lot of the things that we look in kindergarten are essentials in our life. Jesus. What? Oh my god. A lot of the things that we're looking in the kindergarten are essential to our life. And you may wonder, did you lose your mind? What? Why, Oliver? Why? Oh my god. Little soldier. Oh my god. Jesus. So, Leningrad, Russia. Is she smoking? Oh my god, anyway. But again, the idea of looking at this kindergarten, what is the thing that we look at kindergarten? A program? Yeah, kindergarten program. Let me see if Khan Academy actually help here. I'm looking at the basic, bro. It's like, what? Kids free fun education, kindergarten, counting and cardinality. Why is this? Oh my god. Oh my French toast guy, bro. Go to the basic. Oh, S. Oh, S, bro. Oh, S. Oh, S. Oh my god. It's really necessary only. Exactly. Oh my god. Counting geo. No way. Oh, for French toast. Operations in algebraic thinking, numbers and operation in base 10 measurement. And then you got grade 1, geometry, operation, and algebraic thinking, number of operation, grade 2. But this is the same. Oh, and then you go high school number and quantity, real number. Oh my god. Oh shit. Oh, for French toast. Oh, for French toast. Oh, for French toast. Jesus. Oh no, man. Anyway, oh, fuck. Oh no, I can't. Go to the basics. Go to the basics. High school, which is the real number system quantities, the complex number system, vector and matrix quantity, high school algebra. Now you starting to understand this generalization because after all, algebra is generalization based on patterns that you look in the real world. That's why the word mathematic come from the Greeks, which it means, just paraphrasing, is what one gets to know, what which is known. In Spanish, this is lo que uno llega a aprender, like everything in life. Uh, this is something that you are going to learn, but oh my god, seeing a structure in expression, creating equation, high school functions, linear quadratic and exponential model, and how this function actually can allow you to represent basic things. Uh-huh. It allows you to represent basic things here. Specifically, things that will take a lot of time as a way to see the pattern with this function. Geometry, and it is funny that there is a heavy focus in geometry, bro. Circles expressing geometry property with equation, geometric measurement and dimension, modeling with geometry, and then high school statistic probability. Interpreting categorical and quantity data, and now we scale that to look at things with data. Making inference and justifying conclusion. Conditional probability and rules of probability. Using probability to make decision. Decision making. Oh my god. Holy fuck. Name shade, relative position, name shade, compare shape. Oh my god. Partially coverage, distinguish between defining attributes, triangle and closed tree size, composed to geometry. Oh my god, all of it come from the Pythagoreans, bro. Holy moly. Numbers and operations in base 10. Similar in geometry. Analyze shapes and all of this, identity shape, recognizing shapes, shapes and angles. That's why when you look at all of this particular stuff, it's like, what is the thing that I can get from all of this? It's like, I'm looking at all of these funny things, all of these funny s. But what is this? Acute angles, benchmark, draw panelists, identity, parallels, recognize. Jesus, geometry, bro. Anyway, no, it's okay. Anyway, graph points on the coordinate plane to solve real life problems and mathematical problems. Diga. Okay. This is grade 5. Geometry here. Understanding congruence and similarity using physical models, transparency, and geometry software. Oh my god. Determine reflections, rotations, and scale factors. Holy moly. Anyway. Okay. Anyway. This is something interesting because a lot of the time we're gonna use is all of this basic stuff as a way to solve problems. So, with valid parentheses, it actually was quite the same. This particular problem was as a way to see how, given this collection of elements, okay, how can we now, for example, the valid parentheses here, like this. So how, by looking now at this string, how we can now make sure that this actually follow a valid sequence. and a valid sequence is something that they provide for us. So when order matters here, and as a way to compare something, again, we can use a hash, and if the order matter, we use now a stack for this. And because this is now the ECMAScript, script, is pretty much like doing this one. Alright, and now that we look at this particular problem, the valid parentheses here, or the two sum input array is sorted, where now, because this is already sorted, and you don't want to, even the solution here say, hey, your solution must use only constant extra space. Okay. And because of this, you don't want to this solution to this problem actually be solved that take too much time to be solved. All right. That's why now we need to also the reflection or the challenge here. The challenge here was uh, use geometry, exactly geometry, to solve to represent the problem. Interesting. Use the problem to represent. Use geometry to represent the problem. I think that's one of the few challenges. Yeah, use geometry to represent the problem. Basically, what was that? Use geometry to represent the problem. Because instead of memorizing this, we will know how to do that. So this is also why I put this solution here, like this, as a way to using all of this small block, as you can see here. And now compare that as a way to visualize what we have to do and define. Now here is when we started to use a concept known as the two pointers from this, right? This is what we started to use is the concept as a pointer. What is this? Two pointers here. And you got it. Open up. Like this. This is quite interesting that they're using is now this is a two pointer. I never saw the solution here for this. Oh, okay. Well, actually, my solution here is instead of using is this, okay, instead of using is this, the valid palindrome, instead of actually compare that, I just find another particular way to do this. Okay, all right. But what we're gonna do today is now not only valid parentheses, but also we're gonna do is the bin stack. I think, yeah, the bin stack. All right, let's get into this. No. Okay, bin stack. Okay, that was quite interesting. And the reflection here is exactly use geometry to represent the problem. The reflection is using geometry for represent the problem, and thinking in terms of the problem. Or in this case, because initially it was more like it's like understand the whole problem which is input, input, output, and condition. Exactly. Input, outputs, and condition. And let's go to this one. All right. Let's get into this. This is now the day 10. Day 10 here. All right. Be the stack here. There you got it. That's right. Be the stack. Be the stack. And this is the solution. All right. Let's get into this. So, be the stack. Design a stack that support push, pop, top, and retrieve the minimal element in a constant time. Oh, okay. Implement this. Okay, remember geometry after all. But first, understand is the input and output as well as the condition. Implement the main stack class. Main stack initialize the stack object, which is great. I know how to do that and what is going on behind the scenes using a class, which is just a sort of a soft function to use now the yeah, it's sort of a search function to use now the prototype nature of the language, which is the way of how you can now have access to other property and methods, or aka inheritance. Alright. So main stack initialize the stack objects like this. Void push, okay, initialize the stack object. Void push here, push is initial value. They push the element the val onto the stack. Valid pop, remove the element on the top of the stack. Alright. In top gets the top elements of the stack. Now get the top element of the stack. Exactly. Gets the top element of the stack. Oh, it's like peak. Okay. And the other is that it retrieve the minimal element in the stack. Retrieve the minimal element. The minimal element in the stack. Oh, okay. Oh, okay. Giving this input, main stack. Okay, giving this set of instruction. Push, push, get me. Pull, pop, top, get me. Okay. 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 B stack initially doesn't have anything. Then you push this -2, then you push another element which is 0, then you push another element which is -3, then you wanna get the min. You say get min. Get min. Retrieve the minimal element in the stack. What do you mean by minimal element? Minimal element. Define minimal element, bro. Get min. Oh, okay. So by min you define as an empty element, something like that. Exactly, which is being stack as a way to instantiate this object. All right. Get me actually, of course, is gonna give you that. But you, because you are adding all of these elements as a stack, push, 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 and then you say okay, because this is a stack exactly. So -2 is at the bottom. So 0, no, first is this. Okay. So first is this. Okay. So first is this. So this is the element in here. Okay, let's go to actually do this. Here, let's go to drawbar, right? Let's go to drawbar. Uh, well, because we're gonna change here. That's right. Excellent. Because here, this is now the set of instruction that we're gonna receive as an input, okay? And we want to perform is each one of those operations. So this is now to instantiate that. Okay, so if this is instantiated like this, okay, instantiate the stack element here. All right, and the output is, what is the output of this? From all of this sequence. Okay, the output is this null. All right. Oh, this is the input. Okay, because you're gonna receive is a set of instructions followed by their values, right? So 1, 2, 3, 4, 5, 6, 7, 8, 3, 6, 7, 8. Okay. Alright, do you want to know what is that? So min stack initially is null. So far we don't have any elements there. And I want now to do that. Okay. Okay, this is our inputs. You're gonna receive this set of instructions and that kind of thing. This is the input. Input. Alright. We're gonna receive a set of instructions and that kind of thing. Alright. So first, when we initialize our min stack, it is nothing. Okay, return nothing. So the output, the expected output is this, right? So you get now is this. So this is the output. This is the output. All right. So because we are now working is within a stack, implement a stack class. Which is as a way to see if you truly know what you are doing and how to work and how to play with all of these elements. Initially, since our stack we're adding these elements like this, right? After one another, on top of that. Alright. So here in the stack, initially we're gonna store is this value, right? So this will be is the initial value here. Which is this. We need to bring that here. Alright, so this is our first element here, right? How the F do you? Group selection, frame, flatter. How the F group, bro? There you go. Okay. So this is our first element, right? Or min stack. So min stack is this, the first operation. Okay. The next is push, and we're gonna now do this. So hey, I want you to now push this. We need to now push this. What is this? Well, I need to push this 2, -2 element. Okay. So good. Let me do that. I'm now going to push is -2, like this. All right. So that's right. When it comes to the other operation here, I need to actually is do the same. So our output here is showing nothing, right? So our output here is null. So for each one of those operations is null, right? Is null. Okay, is null. Is null. Followed by this is null. And then you got it. Perfect. The next operation is now 0. Okay, so well, this is now 0. Because this is a push operation, again, we're not going to return anything. Cool. The next is the get mid. All right. So how do you get the mid? Uh, Glad that you asked because we need to here is a 1, 2, 3, 4, 1, 2, 3, 4. Okay, and in the yeah, wait, what? 1, 2, 3, 4. We also need to add another push here. That's right. In this case is this one, -3. That's right. Good. And of course, this operation doesn't return anything. But when it comes to the get mid, all right, we should return something. 1, 2, 3, 4. That's right. So 1, 2, 3, 4. We need to return something, which is what is the mid value of this. So in this case is well, this one is -3. So we need to find a way to track that. We need to find a way to track that. How so? Well, we can use an object or a variable to store that value. Good. Next one is pop. So this operation called pop here now is going to remove the element from that. So now pop remove if the element here. You're gonna remove this element, okay? A better way to actually visualize this, it'll be that the first iteration will be something like this. All right, the first instruction will be like this. You can say it's like, well, no. As a way to see this as a sequence of events that's happening, one next to another, which is initially this is one. Wait, yes. This is one. This is operation one. Okay. Then we get now the second operation. Okay. Which is let's go to put this like this as a way to now tell a story here. Okay. So this is what happened one. I'm gonna put this here. This is what happened at 2, the operation 2. But as you can see, you're playing with geometry, bro. You are playing with geometry. Just like that. You're just playing, bro. Play. Like this. Alright. This is one operation. Actually, let me put this at the bottom. Send to back. Of course, this must be. Let's gonna put this like white or transparent. Yeah, that's black. Right, black. Right. Like so. We're gonna actually copy and paste this. It's pretty much what we're gonna do. So the second one operation is this. All right. So the second one operation is this. Where now we're going to actually is bring this element here in the front. Okay. So now this is our push operation here. Bring to the front. Where again this actually return is this one. So the third operation, okay, it'll be like this. So now this time is we're adding is a new element here, which is in this case is 0. It's bring to the front. That's right. Okay, so this is now the push element here. The for operation is where we added now a -3. That's right. So this new slice of telling this story, as you do this, we can actually put a little bit bigger here. All right. Where now this is another push. It doesn't return anything. All right. Where yes, that's right. See what we're putting here. Blah blah blah. Bring to front. Okay. And then the next operation, which is something that you can actually represent again as another slide, as another box, okay, using geometry. And then you say here we got is to actually pop this element. Yep. We're going to actually is now pop this element. And once you do is this, say pop, like so. This one, but this pop actually return is the element, which is in our case we're gonna return is that element. So this particular operation return now that. The next one, okay, is get bid. So the next operation here is to get bid. Yeah, you push. I mean, let me see. It's actually it's like to push. We say 3 push, and then we say Abe is get bid. My bad. Is this? Is get bid? Is get bid, which is -3. That's right. The next one, it'll be now is the 5, which is now a pop operation. Okay. Which is now a pop operation like this, which means that we're going to remove now this element here. We're going to remove now this element here. We're going to remove now this element. You get B, pop. Pop doesn't return anything. That's quite interesting. Pop doesn't return anything, really. You got push. You got get B. You pop doesn't return anything. All right. You got top. Exactly. You got now top. You got now top, because we already removed these elements and we're not going to return anything, which is null. We remove that. Okay. We're going to return now what we have in the top, which is, well, 0. Which is here. Okay. Followed by the top. All right. And the other is get bid, which is something that we must have been updated there. For example, this, which is bid, get bid, which is -2. So as you can see here, now how with doing this, we can just represent all of these different stage of what we are what we have to do. So with the min stack, we can now is actually say, hey, whatever value that we're receiving in our constructor as a stack, say the stack, all right, it'll be now assigned to any particular property that we have called here, called this dot stack, which will be is the stack. All right, so we're receiving is that. Okay, so far so good. That's right. Let me actually put the code here. The next one is to implement now the push operation. So, well, and because now the bin stack actually doesn't return anything, exactly, it's null. Construction behind the scenes doesn't return anything. So the next operation is push, and here we go to now. Actually, is add that element that we're receiving. So because we already defined is this stack here. Now I want to access to this stack like so. All right. And I want you to now push these elements at the bottom. So I say is push, or in this case at the top, which is the last element. All right. I want you to push all of these elements in this particular order, which is, hey, whatever number we receive. So far so good. No problem at all. The next one is push, okay, which is 0. We're not returning anything. Okay, we're not returning anything. So if we don't put this, we're actually not returning anything, which is great. The other is another push. So we're adding now this element 2 as well. But we're not returning anything. However, when we get now to the get min, is when we need to have a way to actually keep track of that last value that we get. So one way to do that, all right, is to store that min value. Say min value here, you can say, hey, this is what it is minus infinite. Okay. As a way to store is a very small value there. And anytime we're actually going to push this value, we're gonna check against that value and update it. Which is, hey, if this dot min value is or is this number, is the value that we're getting less than this min value, I want you to is, well, update this value, or let me see here, is this value is less, I think it's this, if the value is greater than this value, wait a single moment. Okay. So it's 5, if this value is greater than 3, fault. Okay. Exactly. If this value is greater than that, that's right. So if this value is less than this minimum, okay. So if this value, is greater than this min value, all right. So what you're gonna do is from their position, I want you to now see if that actually and put that in that position. So update that min value to that. Yeah, because the whole point of doing this is to say, hey, if this value is infinite, and if there is, of course, there cannot be an infinite value less than infinite. Here's what we put philosophical and that kind of thing. So we can say, hey, if this min value is, or is this value that we're receiving is less than this min value, another thing that we can do is to actually put this min value initially, all right, which is make this be make the first time this the value here. You can say, hey, if this stack contains any element, all right. If the stack does length actually is greater than 1, or greater than 0, which means contains any element, okay. I want you to make now is that element that you receive the as the mean value. You know, mean value will be that. All right. If the element is stack length uh, is equal to 1, which is the first time, okay. I want you to now make this mean value as the val, right? So if we already have one element, I want you to make that element the mean value. All right. So yeah. So however, if we already have a lot of elements here, I just wanted to now check, okay, if this stack contains more than one value. All right, contains more than one value. For every value that we're going to attach, I want you to now check if this actually is greater than that, which is this dot stack or this mean value is less than the val, is less than the value. So make that value mean value equal to the val, right? As a way to store that. Okay. Then we go now to add that element to that. So, or if this mean value that we get, because initially we're appending that mean value to that, right? When you have got one element here. And the other now is when you go to implement other operations. So for example, now they get mean. So we get mean here. We can say, hey, return is this. Return this dot. Return whatever you have stored in this object called mean value. And when you go to pop that element, okay, when you go to pop that element, there are a couple of things that you want to do. First is to check if this element actually check if the element that we're removing. First, we're going to let's go to start with the thing that we can specify quickly, and that is this dot stack dot pop. All right, I want you to now remove that element. But before that, I want you to make sure that that element that we are popping, which is I just want to initially read that element, okay, which is this dot stack dot length, which is this dot stack dot length -1. I want you to read that element first and check if this is less than the this is mean value or the say element. All right, I want to check if this particular element that we're reading here, which is element here, hey, if this element is less than the then the this dot value, because here the idea here is to update is this thing that we'll keep tracking, the mean value, right? uh, so you can see there is a quite interesting challenge because we are storing is uh, because we are storing now is in a variable is what is the list value. We also need to store is what is the previous value, what is the previous list value. Why is that? Because anytime we remove this element here, and if this element that we remove is the least one, okay, we want to now, yeah, anytime we remove this element here, and if this is the least element, we want to know somehow a record of what is the last value and the previous value. You know, interesting. Why is that? Because here we want is to update now uh, with the previous value. Because if this element is greater than this value, it doesn't matter. All right, it's like, hey, we don't need to update this. However, but if this element is less than the beta value, we need to find somehow as a way to keep track that and also update that. Which okay, how can we do that? We can have is a mean value, all right, and after we read that. Yeah, and after we read that, one way to do that when you pop an element here is to somehow store is what is the previous lesser value. So store is these two reference here, which is the mid value, okay, and the so the mean value and the left mean value. Why is that? You're gonna store is the mean value. You're gonna store is the mean value, all right. But you also want to know is what is the reference of this another value, or the lesser value. So it will be is the mean value here, all right, and the other is the next value, next mean value. You know what I mean? Why is that? As a way to now store is these two elements, and when you remove is a new value, the mean value, you want to update that with the new one without actually to iterate through the entire collection. I hope that makes sense. I hope that makes sense. But the whole point of this is to put some reference here. So initially, this will be this. This mean value will be eval. The same for this. This is the first time. Okay. In here, we're gonna check some logic here. Hey, if this mean value is less than val, okay, which means the mean value, okay. Another way to record this in a more easy way is to also have now because the idea here is to store is the mean value. Why is this? You want to hold a pointer to what is the two mean values here, which is, hey, this mean value is, if this mean value is less than value, okay, we want to is update the next min value to this. Update the next min value to this. So the next min value will be is now the min value. This dot min value, and then this dot value of this min value will be now is the value. So the idea here is to actually update and keep track of these two numbers here. Why is that? Well, because when we need to remove them, and then we say, hey, if this element is less than the mean value, okay, I want you to now update that value, which is this dot uh, next value, this dot next value, this dot mean value. I want you to update that to be now the this dot mean value. Okay. So if these elements that we're reading is the same, is the mean value exactly. If the element that we're reading is the mean value, I want you to now update the trackers here. So this update tracker, which is the mean value, I want to now make the that element that we're removing that element that we're removing from that to become is now is the next mean value. Okay, this mean dot value will be the this dot next mean value, and then this dot next mean value exactly. It's just a way to update that. It's just as a way to update the mean value to the next value, and then you remove that. And when you add that again, you want to see if the mean value is less than 1. The other is top. The other is top as a way to get down what is on the top, which is return what you have now in this stack. This is stack here, which is the length. This is stack dot length -1. Remove that, and that'll be all for this. So if I run this code, it say, hey, it's like minus if it doesn't exist. Property stack does not exist on time in the stack. Oh, I need to define that. Okay, so this is not stack. Stack, which is an array. All right. The mean value, which is 0 or minus infinite, is saying, hey, property mean value does not exist on the mean stack. Cannot find name infinite. Minus 0. That actually work. And the next mean value, which is minus infinite, like so. This is where how we can represent now these small infinitesimal numbers. Numbers only refer to a type, but it's being used as a value here. Numbers. What is number? In which line 23? Because it's val, bro. If the stack dot length cannot read property of undefined, read it length. I think it's this. Maybe because I misspelled that. If this does stack dot length, yeah, I misspelled that. Yeah, I did. Cannot read property of undefined reading length. And in this case, this is private, la verdad. Private. Private followed by private. Oh, okay. But if you're not receiving anything, okay. Okay. Yeah, most of the time is when we adding this element here. Okay. Okay. Exactly. Exactly. If this element already contains more than that, so my logic is my logic maybe is when you implement now the beep get me and get me. What about no? Okay, no. Hey, if this being value is less than val, I want you to update that. Okay, I want you to update that. So that's right. If this being value is less than val, I want you to update it. Oh, I mean it's because it's less or equal. hey, this next mean value will be the mean value. Exactly, and then this mean value will be the second value. So here we're updating is the mean value for that. And when it comes to actually remove that element from there, okay, these just stack dot length greater than 1, exactly. This the next mean value here is this dot mean value, exactly. And then the mean value will be is the val, this new value. All right. But it has to be less. If this mean value is less than the val, as you can see here, well, exactly, if this is the less value, because initially we updated that. But if this stack dot length actually contains more element, more than 0 element, okay, I want you to now check this, okay, as a way to check the value that we're receiving here, where at that moment must be is minus 3. Well, it's not going to, okay. Exactly, minus 2, 0, minus 3. Alright. It seems like it's not getting here. Perhaps we're not making reference properly? Exactly. Wait, what? Exactly, it's minus 2. The next one is minus 3. Exactly, it's minus 2. Is enter here. We are comparing that, hey, this stack actually contains more than one element. Yes, it is. I want you to now is, let me get rid of this. Hey, if this mean value is less than the current value that we're receiving, which is 3, then I want you to update the mean value. Then I want you to update the next mean value followed by this mean value. Alright? Which is now is the current value that we're receiving. But now when the time is to actually pop the element here, to pop the element here, which is here, get mean as a way to read the get mean value, it say, hey, this dot mean value is this one. This is quite interesting. Exactly, the last one. after this, it's supposed to be updated. Okay, if this will be value is greater, okay, if this will be okay, okay, my problem is with the opening and closing. Okay, this is my error. Okay, this is my. So if this be value is greater than the current value, I want you to now update that. That makes sense. That makes sense. That makes sense. Okay, logic here. Okay, logic, logic. Okay, so if this be value, if this be value is greater than the value, oh, that's quite fucked up. Oh, okay. Map.apps. No, map.apps. Okay, no. Here we are entering the realm of shit that doesn't supposed to be like. Okay. Map.apps. Okay, this should work, bitch. Exactly. Fuck them. Fuck them. Fuck them. Transform them into an absolute value, and from there I can actually measure them correctly. Oh shit! It's not about comparison. It's now the real number. God. Oh, okay. This is another challenge, but it's like, So challenge here was not logic. Is uh number uh, representation, or in this case, real number representation when it comes to compare. Uh-huh. Real number representation when it comes to compare negative with positive. Uh-huh. Real numbers representation when it comes to compare greater or equal, greater or lesser, negative with positive numbers. Use absolute values or math.apps. When you want to compare them. Okay, and now this is supposed to work as expected. So when I run this, what you can say here, last element. And they use a made this one. And I run this. Okay, but I got some error here when it comes to do this. Okay. Here we go. Zero values and that kind of shit. Okay. Okay. Okay, doesn't matter. It doesn't matter. No problem. No problem. This what it has, what it show is that there's a particular use case to handle this because the get meme we actually keep track that element properly, which which is good. You know, get me. We track that element properly. Except this, get me pop and get me. All right, no, that's fine. That's fine. Yeah, that's fine. That's fine. No problem. So now it's time to actually see how you can solve. Exactly. Uh-huh. The getting the minimum. Uh-huh. But the idea here is to do that. Unless you have no, consider each node in the stack having a minimum value. Oh, okay. 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 There's another way of how you can do that. Let's go to store. Is that exactly? Okay, okay, that's a one good way. Okay, that makes a lot of sense because you got that information there. The other way of doing is you defining some logic as a way to keep track of that. And when you include that, is like when you talk about logic, then you need to talk about is how you're going to maintain that logic. It's like, okay, okay, Yeah, because the other is to put a is to on each one of them is to it's because you need to keep track of that. After all, anytime you're gonna add, you need to define a logic to keep track of that. So logic no. The other is that anytime you add a number, okay, yeah, anytime you add a number, okay, you have a mean stack. What you're gonna do is to only pick that. It's like, hey, what is it? Let me take a look at this, okay, and so on and so forth. Holy moly! All right, that'll be all for this video. Take care. Bye bye.